Hello students, today we will be solving another paper from Pure Maths, paper 1, variant 2. This is from March 2016. Question number 1. We need to find the coefficients of x to the power 4 and x to the power 5 in the expansion of 1 minus 2x to the power 5. So for that, we need to think of how will we be getting x to the power 4. For that, we chose 5c4 and then 5 minus 4, which is 1. So 1 to the power 1 and minus 2x to the power 4, which gives us 5 times 1 times 16x to the power 4. So that comes down to 80x to the power 4. For the coefficient of x to the power 5, we need 5c5. So this will become 5 minus 5, which is 0. So 1 to the power 0 and minus 2x to the power 5. That gives us 1 times 1 times negative 32x to the power 5, which is negative 32x to the power 5. So the coefficients are 80 and minus 32. Now for the second part of the question, it is given that when 1 plus px and 1 minus 2x to the power 5 is expanded, there is no term in x to the power 5. That means the coefficient of x to the power 5 is 0. We need to find the value of the constant p. So what we are doing here, we are basically multiplying from this value, which is 1. We need to multiply 1 with the coefficient of x to the power 5 from the expansion we got earlier of this one. So the coefficient of x to the power 5 was negative 32. And again, if we need to get the expansion, if we need to get the coefficient of x to the power 5, we need to multiply px with the coefficient of x to the power 4, which was 80. That will give us 80 px to the power 5. Now, according to the question, we need to sum these two, and that should be equal to 0. Because negative 32, the coefficients of x to the power 5 for the expansion of this whole thing, which is negative 32 plus 80p, is 0 because there is no term in x to the power 5. That way, we can say that p is equals to 32 over 80. Therefore, p is equals to 2 over 5. Question number 2. A curve for which dy by dx is equals to 3x square minus 2 over x cube. It passes through negative 1 and 3. We need to find the equation of the curve. So since we are provided with dy by dx, we need to integrate this equation to find the expression for the equation of the curve. So integrating 3x square, we get x cube. And if we integrate this one, so this will be minus 3 plus 1, which is minus 2. And minus 2 over minus 2 will give us positive 1. And this will become x to the power minus 2 plus c. Now, since this point passes through the curve, this will help us to find the constant. So we simply substitute the x and y value into this equation, and we get 3 is equals to minus 1 whole cube plus minus 1 to the power minus 2 plus c. Eventually, we get c is equals to 3. So the equation of the curve must be y is equals to x to the power 3 plus x to the power minus 2 plus 3. Question number 3. The 12th term of an arithmetic progression is 17. And the sum of the first 31 terms is 1023. We need to find the 31st term. So this is giving a hint that it will eventually be a simultaneous equation, so that we can find the first term and the common difference for the arithmetic progression. So sum of 31 terms is 1023, and we can use the formula n by 2 within brackets 2a plus n minus 1 times d. So n minus 1 is 30, so that will be 2a plus 30d, which is equals to 1023. Simplifying this, we get 31 times 2a plus 30d, which is equals to 2046. So 2a plus 30d is equals to 66. Also, Since the 12th term is 17, that means a plus n minus 1 times d. So 12 minus 1 is 11. A plus 11d is 17. So a must be 17 minus 11d. So now if we solve this equation by substitution, we can say that 2, instead of a, we can write 17 minus 11d plus 30d is equals to 66. If we solve this further, we get 34 minus 22d plus 30d is equals to 66. Therefore, 8d must be 32. Therefore, d must be 4. Now we can substitute this into this equation to get a. So a will be 17 minus 11, which is 17 minus 11 times 4, which is negative 27. So now with the help of a and d, we need to find the 31st term. So the 31st term must be a plus n minus 1 times d. So a is minus 27 and 31 minus 1 times d is 4. That gives us minus 27 plus 120, which is 93. Question number 4. Solve the equation sine inverse of 3x equals to negative pi by 3. We need to give the solution in an exact form. So sine inverse 3x is equals to negative pi by 3. That means 3x must be sine of negative pi by 3. And negative pi by 3 means it's in the 4th quadrant. So 3x is equals to negative root over 3 by 2. Because sine pi by 3 basically means sine 60. And sine 60 is root 3 by 2. And since it's in the 4th quadrant, which belongs to cos, that means it will be negative. So x is equals to negative root 3 over 6. Part B, it says solve by factorizing the equation 2 cos theta sine theta minus 2 cos theta minus sine theta plus 1 equals to 0 for theta lies between 0 and pi. Now if we take 2 cos theta common, then we get sine theta minus 1. And then if we take minus 1 common, we get sine theta minus 1. So the factors are 2 cos theta minus 1 and sine theta minus 1 equals to 0. So cos theta must be positive half and sine theta should be positive 1. Now let's find the basic angle. The basic angle is cos inverse of half, which gives us pi by 3. And the basic angle of this will be sine inverse of 1, which is pi by 2. Now, we know that theta lies between 0 and pi. And cos is positive. So that means cos positive belongs to the 1st and 4th quadrant. But since our limit is within 90, that means we can only take the value from the 1st quadrant. Similarly, again sine is positive in this 1st and 2nd quadrant. But since theta lies between 0 and pi, we can take both of them. So theta will be, the basic angle is the actual angle pi by 3. And for this, it will be just pi by 2. Even if you consider the 2nd quadrant, so for the 2nd quadrant, we know that we need to subtract the basic angle from pi or 180. So pi minus pi by 2 is again pi by 2. So though we don't have to write this twice. So the angles must be pi by 3 and pi by 2. Question number 5. 2 points have coordinates A 5, 7 and B 9, minus 1. We need to find the equation of the perpendicular bisector of AB. First, let's find the gradient of AB. So that will be y2 minus y1 over x2 minus x1, which means minus 1 minus 7 over 9 minus 5. That gives us negative 2. So the gradient of the perpendicular bisector must be negative reciprocal of this number, which gives us positive half. And since it's bisecting, we need the midpoint of the coordinate AB. So that will be x1 plus x2 divided by 2 and y1 plus y2 divided by 2. So that will be 5 plus 9 divided by 2 and 7 minus 1 divided by 2. which gives us 7 and 3. So now we have the gradient, and we also know the point through which the line will pass through, and that is required to form the equation of a line. So the required equation must be y minus y1 equals mx minus x1. So y minus 3 equals half x minus 7. Now if I cross multiply, we get 2y minus 6 is equals to x minus 7. So 2y is equals to x minus 1. Then it says the line through C, 1, 2, parallel to AB, meets the perpendicular bisector of AB at the point X. We need to find by calculation the distance bx. And this question is of 5 marks, so we have to do a bit of thinking. So first, what we need to do, we need to find the equation of the line through C. And since the line through C is parallel to AB, that means the gradient of the line AB is also the same as the gradient of the line which is passing through C. So, and we also know the point. So that point satisfies this line. So since they are parallel, they have the same gradient. So y minus y1 is equals to mx minus x1. That means y minus 2 is equals to negative 2x minus 1. So y minus 2 is equals to minus 2x plus 2, which gives us y equals to minus 2x plus 4. So this is the equation of this line, which is parallel to AB. That means having the same gradient as AB, and it is passing through the point C1, 2. Now, at x, y is equals to y. X is the point where the perpendicular bisector of AB and the line that they're talking about, they're gonna meet. That means they will be sharing a common point. And we know when two equations intersect, we can say y is equals to y. So this is the equation of the line which we got, which is minus 2x plus 4. This is equals to the equation of the perpendicular bisector which we got previously. That was 2y is equals to x minus 1. Now if we make y the subject, then it becomes half x minus half. So since they are meeting, y equals to y, this is the equation of the line, and this is the equation of the perpendicular bisector. They are gonna meet at the point x. So minus 4x plus 8 is equals to x minus 1. So I have just cross multiplied 2 with both of them. So now we have minus 5x equals to negative 9. And equation of the perpendicular bisector, this was the equation. And I have already explained you how I got half x minus half. Now, if we solve this, we will get x is equals to 1.8. This is the x coordinate for the point x. And if we substitute this value into the equation of the line, then we get the y value as well. So that will be minus 2 times 1.8 plus 4, which gives us 0.4. So the x coordinate will be the coordinate for the x point will be 1.8 and 0.4. Now in order to find the length bx, which is the same as finding the distance, we know the coordinate for b, which was 9 and minus 1. So the length will be square root of x2 minus x1 whole square plus y2 minus y1 whole square. That gives us 9 minus 1.8 whole square plus minus 1 minus 0.4 whole square, which gives us bx is equals to 7.33. Question number 6. A vacuum flask for keeping drinks hot is modeled as a closed cylinder in which the internal radius is r centimeter and the internal height is h centimeter. The volume of the flask is 1000 cm cube. A flask is most efficient when the total internal surface area a centimeter square is a minimum. We need to show that a is equals to 2 pi r square plus 2000 over r. And if you look closely for the show that part, you can see that there is no h in the equation. So first let's find the volume of the cylinder. Volume of the cylinder will be pi r square h, and we are provided with the volume which is 1000. So 1000 is equals to pi r square h. So if we make h the subject, it will be 1000 over pi r square. Now for the surface area, since it is a closed cylinder, that means it is not hollow, of course. We also need to consider the area at the top and the area at the bottom and the area around it. So it will be, the top area is a circular shape as well as the bottom. So it will be pi r square plus 2 pi r h. 2 pi r is the circumference and h is the height, which gives us the surface area of the curved part, that is 2 pi r h. So 2 pi r square plus 2 pi r h, if we simplify this, now we just need to substitute the value of h into this equation, and we get 2 pi r square plus 2 pi r 1000 over pi r square. Simplifying this further, we get 2 pi r square plus 2000 over r. This pi and this pi will cancel, and we have 1 r in the numerator and 2 r in the denominator. So it will be just r in the denominator. In the second part, given that r can vary, find the value of r correct to one decimal place, for which a has a stationary value, and verify that the flask is most efficient when r takes this value. So previously we have already shown that a is equals to 2 pi r square plus 2000 over r, or we can write it as 2000 r to the power minus 1. So since they're talking about the stationary value, first we need to differentiate this equation, and we must also say that dA by dr is equals to 0, because at stationary point the differentiation must be equals to 0. So this will be 2 times 2, which is 4 pi r, and this will be negative 1 and positive 2000 is negative 2000, r to the power minus 1 is negative 2. Now we can say 4 pi r minus 2000 over r square is equals to 0. After doing LCM, if we take r square to the right hand side by multiplying, this becomes 0, and for the LCM this becomes 4 pi r cube minus 2000. So 4 pi r cube is 2000. That means r must be cube root of 2000 over 4 pi. So r is equals to 5.4193. Now let's find the second derivative, or double differentiation. So d square a by dr square is 4 pi. I'm differentiating this again. So this will be just 4 pi, and this will be negative 2 times negative 2000 is positive 4000. R to the power negative 2 negative 1 is negative 3. So when r is 5.4193, if we substitute this into the second derivative, we get 4 pi plus 4000 over 5.4193 to the power 3, which gives us 37.7. And since this is greater than 0, it is a minimum. Question number 7 is related to vectors, and it is not in the syllabus at the moment. Question number 8. The function f is such that fx is equals to a square x square minus ax plus 3b for x is less than 1 over 2a, where a and b are constants. For the first part of the question, for the case where f of minus 2 is equals to 4a square minus b plus 8, and for minus 3, 7a square minus b plus 14, we need to find the possible values of a and b. So this was the equation of the function. When we substitute minus 2 into this equation, we get a square minus 2 whole square minus a times minus 2 plus 3b. That gives us positive 4a square plus 2a plus 3b. And when we substitute negative 3 for this equation, we get a square minus 3 whole square minus a times minus 3 plus 3b. That gives us 9a square plus 3a plus 3b. Now, it was given in the question that for the function minus 2, 4a square minus b plus 8, this must be equivalent to what we got over here. So we can say 4a square plus 2a plus 3b, which was this, after we substituted minus 2 into the equation, it should be equal to 4a square minus b plus 8. Simplifying this, we get 2a plus 3b is equals to minus b plus 8. That means 2a plus 4b is equals to 8. We can divide both sides by 2 and we get a plus 2b is equals to 4. That means a is equals to 4 minus 2b. Similarly, when we substituted minus 3 into this equation, we got 9a square plus 3a plus 3b. But the question also said that for minus 3, it will be 7a square minus b plus 14. So we can say that our equation must be equal to 7a square minus b plus 14. Simplifying this, we get 2a square plus 3a plus 4b is equals to 14. Now let's call this equation 2 and this one equation 1. Now, with the help of substitution, we can simply substitute 4 minus 2b into this equation and we get 2 4 minus 2b whole square plus 3 times 4 minus 2b plus 4b equals to 14. As you can see that there is only one unknown in this entire equation, so it is easy for us to find now. So this, we will be expanding it with the help of a minus b whole square, which gives us 16 minus 16b plus 4b square. This will be plus 12 minus 6b plus 4b equals to 14. Simplifying this, we get 8b square minus 34b plus 30 is equals to 0. Now we can simplify this further by dividing both sides of the equation by 2. You can only simplify by dividing by 2 only if you have something like equals to 0. Then only you can divide both sides. So 4b square minus 17b plus 15 is equals to 0. And we know that 15 4s are 60. At the same time, negative 12, negative 5 gives us negative 16, and negative 12 times negative 5 gives us positive 60. So 4b square minus 12b minus 5b plus 15 is equals to 0. If we take 4b common, we get b minus 3. And if we take negative 5 common, we again get b minus 3. So the factors are 4b minus 5 and b minus 3. So b must be 5 by 4 and b must be 3. When b is 5 by 4, if we substitute this into this equation, we get 4 minus 2 times 5 over 4. That gives us a is equals to 3 over 2. When b is equals to 3, a is equals to 4 minus 2 times 3. That gives us negative 2. So the values are a is negative 2 and b is equals to 3. Also, a is 3 by 2 and b is 5 by 4. For the second part of the question, for the case where a is equals to 1 and b is equals to negative 1, we need to find an expression for the inverse of the function, and we need to also give the domain for the function. So first, let's remember what was the function originally. It was a square x square minus ax plus 3b, and the domain was x is less than 1 over 2a. Most of the students forget to deal with the domain when things change, so make sure that you don't forget about it. So when I substitute a1 and b negative 1, I get 1 square x square minus 1 times x plus 3 times negative 1, which gives us x square minus x minus 3. And also, this one is affecting the domain as well, so it will be x is less than or equal to positive half. Now let's consider y is equals to fx. So y is equals to x square minus x minus 3. And remember that when you are trying to find the inverse of the function, and if it is a quadratic equation, you always have to do the completing square. It's easier to do that. So first we take x, then the sign negative, and we have a 1 next to x, so it will be 1 by 2 whole square minus whatever we have here, which is half whole square, minus 3. Simplifying this, we get x minus half whole square minus 1 by 4 minus 3. Simplifying this further, we get x minus half whole square minus 13 over 4. So now let's make this the subject of the equation. So x minus half whole square is equals to y plus 13 by 4. So x minus half must be plus minus square root of y plus 13 over 4. So x must be half plus minus square root of y plus 13 over 4. And we know that f inverse of y is equals to x. Because if y is equals to fx, that means f inverse of y must be x. So we can now substitute this equation over here. So f inverse of y is half plus minus square root of y plus 13 over 4. So f inverse of x must be half plus minus square root of x plus 13 over 4. Since x is less than positive half, that was the domain. So f inverse of x must be half minus. We should not be taking the plus sign because that will increase. It will go beyond half. It must be less than half. So it will be half minus square root of x plus 13 over 4. Now, domain of f inverse of x is equal to range of fx. This is how we will always be finding, doesn't matter whether they're asking for the domain or range of f inverse. If it is the domain that they're looking for the inverse function, we will be finding the range of the original function and vice versa. So fx is equals to, this was the original equation. Fx is x minus half square minus 13 by 4. This was the equation we got by doing completing square. And we know that from completing square, we get the turning point of the equation. And since it's a quadratic equation, that means the curve, positive quadratic equation, the curve will be having a U shape, and the turning point will be at positive half and negative 13 by 4. So since the range for the domain of fx, domain is x is less than half, this was the domain. So the range of fx will be, the curve goes upwards. So it will be greater than negative 13 by 4, the range of fx. That means the domain of f inverse must be x is greater or equal to negative 13 by 4. Question number 9. In figure 1, OAB is a sector. So OAB is a sector of a circle with center O and radius R. AX is the tangent at A. So this is the tangent at A. To the arc AB, they are talking about this arc. The angle BAX, this angle BAX is alpha. We need to show that angle AOB, this angle is 2 alpha. We know that the tangent and the circle, the tangent and the radius, since OA is the radius, so that means the tangent and radius, they will always meet at 90 degree. And it is also given in the question. So I'm saying that OAB, this angle, is pi by 2 minus alpha, and the triangle AOB is isosceles because these are the two equal sides. So that means OA must be equal to OB. So this is equals to this, and therefore the angles to the opposite equal sides must have the same angles as well. So OAB is equals to OBA, which is pi by 2 minus alpha. So AOB is equals to, which is the required angle AOB. So what we can do, we can subtract from pi these two angles, this one and this one. The total angle is 180, which is pi in radians. So twice of this angle, since there are two of them, so this will give us pi minus pi plus 2 pi, which gives us, so this is alpha. So this will be AOB will be just 2 alpha. In the second part of the question, we need to find the area of the shaded segment in terms of R and alpha. So this is the shaded segment that they're talking about, and as you can see, this is a minor segment. And you should know that area of the minor segment, the formula that we use is half r squared theta minus sine theta. So if we use the formula half r square within brackets theta minus sine theta, we have already found the theta, which is 2 alpha. So it will be half r square 2 alpha minus sine 2 alpha. And that will be it, because they have told us to express in terms of r and alpha. In the next part of the question, it says in figure 2, ABC is an equilateral triangle of side 4 centimeter. So this is the triangle they are talking about with side 4 centimeter. The lines AX, BX, and CX are tangents to the equal circular arcs AB and BC and CA. Use the results in part A to find the area of the shaded region, giving your answer in terms of pi and root 3. The lines AX, BX, and CX are tangents to the equal circular arcs AB, BC, and CA. Use the results in part A to find the area of the shaded region, giving your answer in terms of pi and root 3. So in order to solve this, to give you a better idea, what I did is, this is the new triangle, and previously they gave us this diagram. So if I combine these two, you get a better perspective. So in triangle AOB, where the radius is now 4, because this equilateral triangle is getting joined with the circular arc, or we can say the triangle is getting joined with the sector. So area of the minor segment now, using the formula which is half r squared theta minus sine theta, where radius is 4 and theta is pi by 3. The reason why this is pi by 3 is because for this equilateral triangle, we know that the default each interior angle must be 60 degree, and the line AX is bisecting this angle, so it becomes 30-30, and AX is the tangent meeting the radius at 90 degree. So if this is 30, this will be 90 minus 30, which is 60. So if this is 60, similarly this will also be 60, therefore this must be 60. So this is in degrees. That means we can say this in radians, pi by 3. So half r squared theta minus sine theta will be half times 4 square minus pi by 3, half times 4 square within brackets pi by 3 minus sine pi by 3, which gives us 8 times pi by 3 minus square root of 3 by 2. Sine pi by 3 is basically sine 60, and sine 60 is root 3 by 2. So this is the area of the minor segment, which is shaded in yellow color, in blue color. Now, area of triangle ABC. We can use the formula half AB sine theta. So it will be half times A times B times sine 60 degree, the angle between the two sides. So half times 4 times sine pi by 3 is 8 root 3 by 2, which is 4 root 3. Now, to find the required area, what we can do is, this is the total area of the triangle, and we need to take away 3 times of this area of the minor segment. So if we take away this area, and this area, this white area and this white area, from the area of the triangle, we are left with the area of the shaded region. So the required area is the total area of the triangle minus 3 times of the minor segment, which we got here. Simplifying this, we get 4 root 3 minus 8 pi plus 12 root 3. That gives us 16 root 3 minus 8 pi. And we are told to leave our answer in terms of pi and root 3. So this is our final answer. Question number 10. The diagram shows part of the curve y is equals to 1 over 16 times 3x minus 1 whole square, which touches the x-axis at the point P. So since it touches the x-axis at point P, that means what we know for sure is the y-coordinate must be 0 since it's in the x-axis. The point Q is 3, 4 that lies on the curve, and the tangent to the curve at Q, there is a tangent at Q, crosses the x-axis at R. Again, we know that the y-coordinate for the point R must be 0 as well. First, we need to state the x-coordinate of P. So this is the equation of the curve that we have. Simply, we can say at P, y is equals to 0. So 0 is equals to 3x minus 1 whole square over 16. Then it becomes 3x minus 1 whole square equals to 0. That means 3x minus 1 is equals to 0. So 3x is equals to 1. Therefore, x is equals to 1 over 3. In the second part of the question, it says, showing all necessary working, find by calculation the x-coordinate of R. And this is of 5 marks. So we need to do a bit of thinking. So the equation that we have, this one, is of the curve. We need to differentiate this equation so that we can get the equation of the gradient for the tangent of the curve. So this will be 1/8 of 3x minus 1, and then this is in outside differentiation. I'm just differentiating the power first. So this will be 2 minus 1, which is 1, and the power 2 will come over here. 2 over 16 becomes 1 over 8, and then inside differentiation we get 3. Now when we substitute the value of x, which is 3, we get the value for the gradient, which is for the tangent at the point Q. So dy by dx is equals to 1/8 of 9 minus 1 times 3. That gives us 3. So equation of the tangent. So we are basically finding the equation of the tangent with the help of the point 3, 4, because 3, 4 is the point Q. And we have also found the gradient of the tangent at the point Q, which is 3. So y minus y1 equals to mx minus x1. That means y minus 4 is equals to 3 times x minus 3. So y minus 4 is equals to 3x minus 9. So y will be equal to 3x minus 5. So this is the equation of the tangent that we got. Now we simply have to substitute y as 0 because this tangent is intersecting with the x-axis. So that means that y must be 0 at x-axis. So 0 is equals to 3x minus 5. So x is 5 over 3. And this is the x-coordinate for the point R. Let's look at it again. So this was the curve. We differentiated to find the gradient of the tangent at the point 3. And we use this point as well, which is 3, 4, and the gradient of the tangent to find the equation of the tangent. Then for finding the x-coordinate of R, we substituted y as 0 into the equation of the tangent. That's how we got the x-coordinate of the point R. In the next part of the question, we need to find the area of the shaded region PQR. So in order to do that, what we can plan is finding the area between the curve and the x-axis first. Also, we can also find the area of this triangle QRS, and then we can take this area away from the area between the curve and the x-axis, which is under the curve. So let's first find the area of the triangle QRS. So half times base times height. So half times the base must be the x coordinate. I'm calling this point S. So x coordinate for the point S will also be 3. So 3 minus 5 by 3. That is the x coordinate for point R. Times 4, because 4 is the height. Y means height. So this y coordinate is the height. So it will give us 8 over 3. It's better to leave it in fractions rather than decimals so that we can avoid accuracy error. Now for the curve, we have 1 over 16 times 3x minus 1 whole square. We need to integrate this first. So 1 over 16 is a constant. So let's take it out. And we are left with integrating 3x minus 1 whole square. For this, power is the operator. That means we need to differentiate 3x minus 1. That gives us 3. So we bring 3 over here and we need to balance the equation, which is 1/3 outside the integration. Then we can simplify this. So this becomes 1 over 48. 16 times 3 is 48. And then these three things will disappear. So the integral sign, differentiation of the box, and dx. And then we can integrate the operator. So 2 plus 1 is 3. And we also need to bring 3 in the denominator. Plus c, because we are just finding the expression right now. So simplifying this, we get 3x minus 1 whole cube over 144 plus c. Now, if I put the limit 3 and 1/3, so 3 is over here, and we need to take the x coordinate of the point P so that we get the area between the curve and the x-axis. So 3x minus 1 cube over 144, and the limits are 3 and 1/3. Substituting these two values, 3 and 1/3, we get 32 over 9. Then the required area must be 32 over 9 minus 8 over 3, which was the area of the triangle. That gives us 8 over 9, and now we can write it in 3 significant figures, which is 0.889. And that will be all for now. I will see you in the next video.